Okay, so as you can see, this is Unit 4, Lesson 3, and it's rational exponents today. Rational just means fractions or decimals, okay? So our exponents today will be fractions or decimals, but have no fear, it's actually quite simple. So here's the law in general, okay? In general, when you have something to a fraction, so in this example here, I have x as my base, okay? And it's raised to the power of a over b. Oh, it's frozen. Whoops, there we go. So I have something x, whatever x is, could be 10, could be 8, doesn't matter. But if x has a power on it that's a fraction, we rewrite it like that. We actually change it to a radical, okay? Whatever the base was, so that's x in this case, whatever the base was, goes underneath the radical right there. And then if you look closely, the denominator, so the b, goes in the little nook. That's called the index, okay? And then the numerator goes as a power on the outside. So the denominator becomes the index, the numerator goes in brackets on the outside, and the base doesn't change. So let's look at this first question. I have 27 to the power of 1 over 3. I'll zoom in a little bit, sorry. 27 to the power of 1 over 3. So whenever you see a fractional exponent, it automatically becomes a radical. Now, the base is 27, so that goes underneath. The denominator is what goes in the index. So because the denominator is 3, it's actually going to become the cube root of 27. And then in this case, because the numerator is just a 1, like that's normally what we would do, right? But you don't need to do that step because putting something to the power of 1 accomplishes nothing. So we actually don't need to put that 1 there. If the numerator is 1, don't worry about it. So all we're actually figuring out is what's the cube root of 27? 3 times 3 times 3, and we're done. Okay, when it's a decimal, don't worry about it. The whole decimal goes underneath. So it's the 0.49 underneath. The denominator is a 2. So that means that that 2 goes in the index. But of course, when it's a square root, when it's a 2, you don't need to write that 2. It's there no matter what. If there's nothing there, there's actually a 2 there. So really it's asking for the square root of 0.49, which is just 0.7. C, I want negative 64 to be the base now. So that negative is in brackets, it's glued to that 64. So when you write this as a radical, make sure you write negative 64 underneath. It belongs to that 64. The denominator of your fraction is a 3. So that's now what your index is. And again, when the numerator is 1, don't worry about doing anything else. A numerator of 1 is easy. So all we're asking for is the cube root of negative 64. Okay, in the last lesson, we could not square root a negative. Impossible. But can we cube root a negative? Is there something times something times something that gives us negative 64? Okay, well, what's the cube root of 64? If you look on our poster, if you look under the perfect threes, there's 64. And then if you look all the way to the left, it's 4. So that means 4 times 4 times 4 is 64. Okay, is negative 4 times negative 4 times negative 4 negative 64? Yes, because 3 negatives, 2 of them cancel out, but 1 of them sticks around. So negative 4 times negative 4 times negative 4 is negative 64. So you are allowed to cube root a negative. You cannot cube root of, sorry, what did I just say? You are allowed to cube root a negative. You cannot square root a negative. such as -4. Okay, here we have 0.5. It's our first decimal. Whenever you see a decimal, the first thing you do is change it to a fraction. What is the fraction of 0.5? Come on. 1/2, a half, right? 0.5 means half. Half in the fraction form is 1/2. So this is actually asking -25 to the power of 1/2. So really the question is asking for the square root of -25. Remember the denominator is 2. That becomes our index. We don't have to write it. What's the square root of -25? We just went over this. We just went over this.
-5.
For people who aren't here right now, you're seeing me get very angry. Okay. It's impossible. You can't square root a negative. Apparently, I need to go over this again. All right. What is, well, that was ugly. What is 5 times 5? Do I want 25? No, I want -25, so that doesn't work. Okay, so then students say, okay, well, it's -5 times -5. Well, what's -5 times -5? It's still positive 25. Then the other option they always say, -5 times +5. Well, sure, that gives us -25, but that's not the definition of a square root. The definition of a square root is something times itself. -5 and 5 are two different numbers. That's not the definition of a square root. It's impossible. You cannot square root a negative. That's the most angry I've ever gotten with you guys. And it wasn't even that bad. Okay, 4/9 to the power of 1/2. It's a fraction, so your base is the fraction 4/9. Don't panic with fractions. Okay, so this becomes the radical, and then that whole 4/9 just goes underneath. Because the denominator is 2, that's what our index is, but you don't need to write it if you don't want to. If you want to write it just to remind yourself, go for it. We're asking for the square root of 4, which is 2, and the square root of 9, which is 3. Done. Again, when the numerator is 1, there's no extra work to do. Okay, 16/81. That's our base. Now, our decimal is 0.25. Whenever you have a decimal exponent, we change it to a fraction. Does anybody know offhand what the fraction is of 0.25, Emily? 1/4, a quarter, right? A quarter, 25 cents, 25, a quarter, 1/4, 1/4, right? Okay, if you did not know how to do that, this is what you do, a little sidebar. Take your decimal, 0.25. You take the decimal point and you bump it until it's off. So I had to move it over twice for it to fall off. Because I moved it over twice, the number is now just a 25, but because I moved it twice, I have to now put it over 100. It's over 100 because 100 has 2 zeros. If I moved it 3 times, the decimal, I put it over 1000 because it has 3 zeros. So because I moved the decimal 2 times, I put it over 100 because it has 2 zeros. Then what you do is you just reduce this fraction. You can divide each of these by 25 to reduce it. So on top, 25 divided by 25 is 1, and on the bottom, 100 divided by 25 is 4. So that's the long way to get 1/4 if you can't just do that in your head. So this is really asking for the radical of 16/81. Your denominator is actually a 4, so that's your index. It's not an index of 2 anymore. It's not a square root. Our denominator changed to a 4, but the numerator is still 1, so we don't do anything extra. So then you just ask yourself, okay, what's the 4th root of 16? Meaning, what times what times what times what? 4 times, which is the identical number, gives us 16. 2, thank you. And down low, what times what times what times what gives us 81? 3. And you are done. Okay, For this next question, G, we're going to kick it up a little bit. This is the first time we don't have a numerator of 1. We have an extra step to do here. But we always, we take that base, which is -8, and it goes underneath. So now you have two things to write in. The denominator is a 3, so your index is actually a 3. But now, because your numerator is not 1 anymore, it's 2, the law says we have to put that 2 outside as a power. Now we simplify what's in the brackets. Are you allowed to cube root a negative? No. Ah! You're not allowed to square root a negative. Yes, you are allowed to cube root a negative because -2 times -2 times -2 gives what we want. Negative is true. -8 has a cube root because there is something that times itself 3 times gives us -8, and it's -2. So I'm going to say this one more time for everybody at home too. You cannot square root a negative, but you can cube root a negative. Okay? So the answer here in brackets, the cube root of -8 is -2. But then it's to the power of 2 because the numerator is 2. So what's -2 squared? Or in other words, -2 times itself. Or in other words, -2 times -2? 4. +4. 2 negatives cancel. Okay, last row. On the far left here, we have 27 to the power of 4 over 3. I'll zoom in a little bit. 27 to the power of 4 over 3. Okay, let's just go. We know it's going to be a radical. We know underneath the radical is going to be 27. We know that the index is whatever the denominator is, so 3. And then we know because the numerator is 4, that 4 is going to be out, just hanging out for us, waiting till the end. So all you do in the brackets is the cube root of 27. So what times what times what is 27? And the answer is just a 3. But then that 3 goes to the power of 4 in the end. And 3 times 3 times 3 times 3 is 81. Okay, this guy. Holy smokes. What am I trying to do to you guys here? So for this one, it's like you just have 2 separate questions, and then we just multiply the answers together in the end. So for the first one, I want the cube root, because that's my denominator, of -8, that's my base, all in brackets to whatever the numerator is, which is 5. Then I want that multiplied to, you change it to a radical of 16. And then my denominator is 4, so that's my index. But because the numerator is 1, we can just stop. No brackets needed. Okay, no one's going to make me angry. Are we allowed to cube root a negative? Yes. The answer is -2. To the power of 5. Then my next guy is the 4th root of 16. So what times what times what times what? 4 times in a row gives me 16, and it's just a nice big 2. We're not quite done. We still have to evaluate what -2 to the 5 is. So -2 times itself 5 times is 32. Now, is it -32 or +32? Negative, because if you have 5 negatives multiplied together, only 4 will cancel out. There will be 1 left over. And so the answer in the end is 32 times 2, 64, but it's of course negative. That's as hard as it can get, really, which wasn't so bad. All right, 2 more and we're done. Saved by the bell. Bell's going to 1024 to the power of 0.4. So off the top of your head, you may not know what the fraction is for 0.4, and that's totally understandable. So this is where you may do that little work to the side. You take your decimal 0.4. I take the decimal point and move it until it falls off. So I moved it once only. So now the number is just a 4, and because I moved it once, what's it going to be over? 10, because 10 has 1 0. And then you reduce because you can divide each of those guys by 2. And so the fraction is 2 over 5 for the decimal 0.4. So now we go back here. I know it's going to become a radical of 1024. What's my index? 5, right? Whatever the denominator is my index. And then because my numerator is something besides 1, it's a 2, I have to throw that out in brackets. Okay, so you evaluate what times what times what times what times what is 1024. And you may remember in the first video, 4.1, you had to watch at home. I actually had like a table in the video with all of the perfect squares, perfect cubes, etc. I'll print that off for you guys so you can have one in your binder. You look at the column of perfect fifths, you would find 1024. You'd look all the way over to the left and you'd see that the answer is 4. 4 times 4 times 4 times 4 times 4. 5 times in a row is 1024, but we can't forget to square it in the end. 4 squared 16. Last one, I think. Yeah, last one. I just wanted to do one more with a fraction where the numerator isn't 1. We haven't done one like that yet. So we always know it's going to become a radical. So it's the radical of the base 81 over 64. The index is the denominator, which is 2. We don't have to write anything then. It's automatically a square root when you don't write anything. But then I want my answer to be to the power of 3 in the end. So in the brackets, you find out, okay, the square root of 81 is 9. Let's write that down. The square root of 64 is 8. Let's write that down. But then we cube it, which essentially means you take that cube and just put it to each one. So I want 9 cubed, and then I want 8 cubed. So on top, 9 times 9 times 9 is 729. And on the bottom, 8 times 8 times 8 is 512. And if ever your answer is a fraction, I always believe that's reduced. Go. And that, my friends, is how you do fractional exponents. Okay, the assignment is written here. There you go. You can jot that down. And then after lunch, you'll have time to finish that up. Okay. Video ending.